So I'm going to explain the basic understanding of basic radiation quantities. This is where we're going to talk about exposure, absorbed dose, and effective dose. But to get a better understanding, we're going to take a look at this picture in regards to this patient laying on the x-ray table. So we know as x-ray techs, what we do is we are going to shoot radiation to this patient. And the first place that the x-ray photons are going to travel is in the air because it's coming out of this tube. So this is where we have air. And this is the exposure. Next, what's going to happen is once it's traveling in the air, it's going to get absorbed in the patient. So this is the absorbed. Again, that's absorbed in the patient. After the absorption, now we're going to talk about its effect on where it gets absorbed, and that's the effective dose. Okay? So what we also learn is exposure used to be measured traditionally in Röntgen, or also known as just R. Now the SI unit is the new unit, and it's coulombs per kilogram. So exposure is in the air. It's always going to be traditionally known as Röntgen, but the SI unit is coulombs per kilogram. Okay? The next one is absorbed. Absorbed traditionally was called rad. It's the radiation absorbed dose. And the SI unit now for rad is gray. Now to remember this, Casey said it best when she said Gray's Anatomy is a rad show. So gray is rad. Also remember the A in rad to absorb. Now we have the effective dose. Effective dose traditionally is REM. And the SI unit is sieverts. You just have to remember the REM E for effective. So exposure is always going to be Röntgen, coulombs per kilogram. Absorbed is always going to be rad and gray. And effective is going to be REM, and sievert. Okay, so now you have to understand this in order to convert it. We know that a Röntgen equals 2.58 times 10 to the negative fourth coulombs per kilogram in the air. Okay. Now, if you are wanting to find the coulombs per kilogram, all you have to do is just cancel this out. So you divide 2.58 times 10 to the negative fourth. And that's where you get equals coulombs per kilogram. So as long as you remember the 2.58 times the 10 to the negative 4 kilograms per kilogram equals a Röntgen, you should be able to easily find what is a coulombs per kilogram. The next one is going to be your rad's dose. Okay. Now we know that 1 rad is going to equal 1 over 100th gray. That's just something that you're always going to have to remember. 1 rad equals 1/100th of gray. Okay. We know that 100 centigrade equals 1 gray. Because it takes 100 of the centigrade to equals 1 gray. And if we were to see how much is 1 centigrade, we just divide it to cancel out. Centigrade equals 1 gray over 100. Now if you look at this is the same as this, meaning 1 centigrade equals 1 rad. The next thing we're going to do is rems. We know that 1 rem equals 1 over 100 sievert. Okay? We know that 100 centisievert equals 1 sievert. And then to find out how much does 1 sievert equals, just cancel out. So 1 sievert equals 1 over 100 sievert. And again, if you look at this is the same as this. Therefore, 1 centisievert equals 1 rem. So if the question is ever asked, what does 200 centisievert equal in rem? Well, that one's easy. That would be 200 rem. If we were to say, 250 centigrade equals how many rads? It would be 250. And again, this is all on page 317 in your book. Use it as reference. Again, you're always going to want to remember that exposure is air, which is Rankine, which also is equivalent to coulombs per kilogram. Absorbed dose is rad with the SI unit of gray. And the effective dose is rem with the SI being sievert.